Aloha, I'm Simon Roschmann, and I would like to introduce our paper, Shortcut Detection with Variational Autoencoders. To deploy machine learning in the real world, we have to ensure that models make predictions based on features that generalize. In particular, the model should be robust against spurious correlations, aka shortcuts in the data. In our paper, we leverage VAEs to discover feature target correlations in datasets, and we semi-automatically evaluate such correlations for shortcuts. First, we train a beta VAE on a given dataset. Here, it's a dataset containing images with lemons of good and bad quality. The VAE discovers independent factors in the data, for example, the color, orientation, or zoom level of the lemons. All these factors are encoded in the VAE's latent dimensions. Second, we identify feature target correlations. On the one hand, we estimate the class-wise distributions for each latent dimension and each target class. We want to find those latent dimensions whose class-wise distributions are highly disparate because they encode information that highly correlate with certain classes. On the other hand, we perform linear probing with a pre-trained and frozen VAE encoder. Eventually, the weights in the linear layer should also denote the correlation between each latent variable and each target class. Third, we evaluate the previously obtained feature target correlations for shortcuts. We visualize latent space traversals for the most predictive dimensions. In the end, a human judge has to identify the meaning of a dimension and determine whether the feature is a valid feature or a shortcut. On the left here, you can see visualizations of latent space traversals. We depict VAE dimensions which represent a spurious attribute. For example, the position of a patient in X-ray scans. All in all, we evaluate our approach on 6 image and audio datasets. We successfully reveal the inherent shortcuts, and we demonstrate the superiority of our method over heat map-based approaches.